Good morning. Welcome to lecture 12 of module 1 in database management system. Today we are going to see how to create an ER diagram. So till now we have seen the different concepts that are required for creation of an ER diagram. So today we are going into the real construction of an ER diagram. So before going into the construction of an ER diagram, let us review the various notations for creation of an ER diagram, okay, that we have already discussed. So this rectangular box represent entity, and this one is elliptical or oval shape represents attributes, and if that attribute is having a underline, which means that it is a key attribute. Okay, this is a normal attribute. Okay, then this one double rectangle implies the weak entity. Okay, so weak entity, we have already discussed the concept of weak entity. Weak entity means that the entity that does not have any primary key or a key attribute, that is called a weak entity. Now this dotted ellipse is called a derived attribute. The example we have already discussed, date of birth and age. So age can be derived from the date of birth. So age is called the derived attribute. Such attributes are represented in dotted ellipse. Okay. So this is a normal attribute, and this is a multi-valued attribute. We have already seen about multi-valued attribute. For example, mobile number. A person can have multiple mobile number. Okay, in order to store multiple values for a particular attribute, we use a multi-valued attribute that is represented by using double ellipse, a double oval shape. Okay. Next is composite attribute. Composite attribute we have already discussed. For example, a name can be, a particular attribute can be subdivided. For example, name. A name will be having first name, last name, and so on. Okay, another example, address. Address can be the street number, city, district, state. Okay, these are the different subparts of a attribute address. Okay, so in order to store the subparts, we use a composite attribute. Okay, this shape, diamond shape, is used to store to tell the relationship. Okay, what is the type of relationship that is involved in the in this ER diagram. Okay, that is the relationship type. So relationship type is represented using this diamond. Now double diamond is used to represent the identifying relationship. What do you mean by an identifying relationship? We have already discussed that. Identifying relationship is actually used to connect a weak entity and a strong entity. Okay, in order to connect a weak entity and strong entity, you will be using this identifying relationship. So using these notations, we can create an ER diagram. Okay, so let us see an example. Example 1. So in university, you will be given certain statements like this, and you after reading the statements, you have to create a ER diagram. Okay, let us discuss. The company database keeps track of company's employee, department, and project. Okay, so here we are storing we want to create a company database. So that company database must contains what all things, company's employee details. So employee means it must be an entity. Okay, department is also an entity type. Okay, project is also an entity type. Okay, we store the employee's name, SSN, address, salary, gender, date of birth, age. Okay, so we have to store all these details of the employee entity. So these SSN, address, salary, gender, date of birth are the attributes of employees. Okay, so attribute of employees involve employee name, SSN, address, salary, gender, date of birth, age. Okay, and employee is assigned to one department. Okay, so I will read each and every statement and create the entity. Okay, in each step I will create start the creation of the entity ER diagram. Okay, so first first we represent what all entities are required. So we have discussed from the first statement itself, which is understood that we require what employee, companies, employee. So employee is an entity, department is another entity, and project is another entity. Okay. So first of all, we draw the three entities. Entity is represented using rectangle. Okay. So employee, department, and project. Okay. Let us see any more entities are coming. Okay, that will be understood only after reading the full statement. Okay. Next, what we do? So first we have created this thing, and the next task, we store the employee's SSN number, SSN, employee name SSN. SSN is a unique identification number for employee. Then address, salary, gender, date of birth, age. So we have to create the attributes for the employee. Okay, so attributes for the employees are name, SSN, address, salary, gender, date of birth. Okay, now let us see the attributes of department. What will be the attributes of the department? An employee is assigned to one department when working on solo project. Each department is having unique name, unique number, and locations, several locations. Okay, so next we'll be having, we'll write the attributes. We'll draw the attributes. So attributes are represented in oval shape, right? Oval shape. So employees, what does the employee entity contain? Employee name is there. Employee SSN. So this SSN is actually a unique identification number. So it is a primary key. Okay, that is why it is underlined. Okay, so SSN is a unique, since it is a unique number. So in question it may not be saying that SSN is a unique number or it is unique. Such statements will not be there. Sometimes it may be there. If it is not there, you have to understand that SSN or such numbers like SSN, serial number, roll number, etc. Such things are actually unique in when you having unique. So unique in nature. So such unique attributes must be represented using represented by an underline. Okay. Next, name, SSN, then employee name, address, okay, address is there, then salary, salary is there, I just left it out. Okay, then gender, okay, then date of birth, age. Okay, now let us see about this one, date of birth and age. Okay, so age is actually what? It is a derived attribute. Okay, in question it is not saying so, but we must understand that this is a derived attribute. Okay, we have already seen the example, because this age can be retrieved from this derived attribute date of birth. If you are knowing the date of birth, we can very well calculate the age. Okay, so that is over. Next, department. So what all the attributes required in the department? Let us see. Each department has a unique name. Okay, unique name, unique number, and several locations. Unique name, unique number. It is given as unique. Okay, so unique means it must be a primary key. Okay, so using these attributes, we can uniquely identify a particular attribute, a particular record. Okay, so unique name and unique number are primary key. Okay, so department number. So this is department number, which is unique. Since it is unique or it is a primary key, we will be underlining it. Okay, then unique name. Name is also unique, so it is also a primary key. So we will be underlining it. Okay, then it is written as several locations, not a single location, several locations. So this location attribute need to store several details, several different locations. Okay, because a department will be placed in different locations. So all those locations must be specified here. So since it is a given as a several location, it is a multi-valued attribute. Okay, since it is given as several locations, this location will be represented as a multi-valued attribute. That is why I have given it as a double ellipse. Okay, clear? The department controls. Okay, next is the project. What about project? What are the attributes in the project? project must have a unique name. Project has a unique name, unique number. Okay, project must be having a unique name and unique number. So this must unique name and unique number, both are unique. So this unique project number is unique, so it is underlined. Project name is also unique, so this must be also underlined. Okay. Then project location. Project location, it is having only a single location, so it is a single value, not multi-value. Okay, so I have just given a single ellipse. Okay. Next, so all those attributes, all those entity I have identified, and one more entity is there, which is dependent. See here, a dependent is also that we will create here. Okay. Next, we create the relation. Let us see this. Read the statement. Employee store employees, birthday, age, and employee is assigned to one department. That is the relationship between employee and department. It is saying that an employee is assigned to one department. An employee is assigned to one department. Okay, so an employee is assigned to one department. Okay, so what is the cardinality here? An employee is assigned to one department. A department can have one employee? No, many employees. A department can have many employees. Okay, so here the cardinality ratio is many to one. Okay, so here you have to create the relationship as well as its cardinality also. You have to mention the cardinality also. Okay, so in the question it is already given that employee is assigned to one department. An employee is assigned to one department. An employee can be a part of only a single department. Okay, clear? The reverse relation is not given, that we have to understand. A department can have multiple employees. Okay, so the cardinality is many to one. Okay, so the first relationship is over. Next one is what? Employee. An employee is assigned to one department but may work on several projects. But may work on, that is, then employee can work on several projects. That is the next relationship. Okay, an employee can work on several projects. That is our next relationship. An employee can work on several projects. Okay, an employee can work on several projects, but it is not necessarily controlled by same department. Okay, so an employee can work on several projects. An employee can work on several projects. So what is the cardinality here? An employee, the question it is given, one employee can work in several projects. Okay, in reverse order, a project can be given to a single employee or multiple employees. That is, both are correct. Okay, so here I am giving multiple employee. Project will be given to multiple employees. Okay, project can be assigned to multiple employees. In IT companies and all, a project or a work or a software development project will not be given to a single employee. It will be given to multiple employees. Okay, so a project can be assigned to multiple employees. So here the cardinality ratio is many to many. Okay, so the cardinality ratio is many to many. Clear? So similarly, you have to read all these statements line by line and have to clear all those things. Okay, clear the relationship, cardinality, and so on. But work on several projects in the same department. A particular employee, another thing, a particular employee manages a department. Okay, so here employee, here a particular employee, a particular employee will be a manager. Okay, and that employee can manage this department. Okay, a single employee will be managing this department. Okay, that's managing is the next relationship that we are going to create. See, an employee manages a particular department. Okay, so here the cardinality, what will be the cardinality ratio? An employee can manage only a single department. Correct? A single employee can manage only a single department. Okay, in reverse way, what will be the cardinality? A single department can managed by only a single employee. Okay, a single department can be managed only by a single department, because each department will be having only a single manager. Each department will not be having many managers or head of the departments. Each department will be having only a single manager or head of the department. So here the cardinality ratio is 1 to 1. Clear? Next, a particular employee manages the department. That is over. Each department has unique name, unique number, and several locations. That we have already filled it out. Each department is having a unique name, unique number, and several locations. That we have already filled it. The department controls the number of projects. Department controls the number of projects, each of which has a unique name, unique number, and single location. So a department, next is department project relationship. A department controls project. Okay, department controls many project. That is the next relationship. Okay, a department, see, a department control many projects. Okay, clear? So a department control number of projects, each of which has a unique name, unique number, and a single location. Clear? So a department controls many projects. So what is the cardinality ratio? A single department can control many projects. Okay, but a project, single project, can be a part of only a single department. So here the cardinality ratio is 1 to many. So 1 to many is the cardinality ratio. Clear? Then the department controls the number of projects, each of which has a unique name, number. The department controls number of projects, each with a unique name, number, and single location, that we have already filled. Okay. Then a new thing, we want to keep the track of dependent of each employee for the insurance purpose. Okay. So we have to create a new entity called a dependent. Okay, that is our next task. We will be creating a new entity called dependent. Why we are creating the dependent? For the employee's insurance purpose. Okay, so for the insurance purpose, we require the dependent's name, date of birth, and so on. Okay, for that we are creating a new entity called dependent. So we are going to create a new entity called dependent. Okay, so we have created a new entity called dependent, and the dependent must contain what all things? First name, sex, birth date, relationship. Okay, here it is not visible, actually it is relationship. So the dependent entity must contain first name, sex, birth date, and relationship. Okay, so I have mentioned these attributes: first name, sex, birth date, relationship. Okay, so from this thing, here is there any unique attribute? See, first name, it is not unique. Name is not considered as a unique attribute. Sex is not considered as a unique attribute. Birth date cannot be a unique attribute. Relationship cannot be a unique attribute. So this entity type does not have a unique key, or does not have a primary key. So such type of entity is called a weak entity. So this dependent is actually a weak entity. So this will not be mentioned in the question. We have to identify it. Okay, it will not be given in the question. So this dependent is a unique, this dependent is a weak entity. That concept we have to understand. Okay, so this dependent is a weak entity. That is why we have given a double rectangle to represent this entity. Okay, so dependent is a weak entity. Why? Because does not have any primary key. Clear? Now this dependent is related with, why this it is weak entity? Because it does not have any primary key, so it has to depend with another entity. The another entity is employee. So it is going to create a relationship with the employee. Okay, let us see. So this is the relationship. Okay, we keep track of dependent first name. We want to keep track of the dependent of each employee. So employee and dependent is having a relationship called a dependent of. Employee is the dependent of this one. Okay. So here the relationship is actually what? Relationship is actually actually the relationship is, so this relationship is called a identifying relationship. Why? Because this relationship is actually connecting a weak entity and a strong entity. So weak entity and strong entity is connected through a identifying relationship. Okay. So since it is a weak entity and it is an identifying relationship, the total participation, here it is having total participation. Why it is having total participation? So this double line signifies a total participation. What is the total participation? This, because this entity cannot exist without the employee entity. Okay, this cannot have any existence if the employee is not there. So this is having total participation. Clear? That is, every entity in this dependent entity type is actually dependent on every entity in the employee entity type. Okay, so for example, if there is dependent 1, dependent D1, D2, D3, and the employee E1, E2, E3, E4, this D1 will be having relationship with E1, D2 will be having relationship with E2, D3 will be having relationship with E3. That means that every entity in dependent is having relationship with the employee. So it is having total participation. But in the reverse order, it is not mandatory. Every employee, it is not required to have a dependent. So because E1, E2, E3 is having dependent, E4 is not having any dependent. Okay, so it is not mandatory to have every employee to have a dependency. So this is a partial participation, this is total participation. So these concepts we have already discussed. So this is an example for an entity creation of an ER diagram. Okay, this is a example for a creation of ER diagram. So in university the questions will be asked like this. Okay, and we can see one more question. Example 2. This is a university question. See, in some questions, the attributes will not be given or the properties of the entity will not be given. In such case, we don't have to write any attribute. Even if they are asking to write the attribute, we can write our own attribute. Okay, our own choice of attribute we can write, no issue. So this is such question. Here the attributes are not given, only the entity and these relationships are given. Clear? So let us see the questions in detail and write the ER diagram step by step. So the first one, a company has the following scenario. There are a set of salesperson. Okay, so we are having a first attribute salesperson. I am drawing the first, sorry, not attribute, the entity type salesperson. So you are having set of salesperson. Some of them manage other salesperson. Okay, so this is our next statement is some of them manage other salesperson. That is, a salesperson in a salesperson entity type, the sum of the salespersons will manage other salespersons. Okay, so this salesperson is having a recursive relationship. That is the next step. Okay, the salesperson manages some salespersons. Okay, but some salespersons can manage other salespersons. Okay, so we can say that a single salesperson can manage several other salespersons. So that single salesperson will be a manager. That is the meaning. Okay, in the other way, what will be the relationship will be like this. Many salesperson will be managed by a single salesperson or a manager. So this is a recursive relationship. So this type of relationship is called a recursive relationship. Okay. So however, a salesperson cannot have more than one manager. A salesperson cannot have more than one manager. That is the meaning. The salesperson cannot have many salesperson cannot have more than one manager. That is the meaning. So a salesperson, many salespersons will be managed by a single salesperson or a manager. Clear? That is the point here. Next point, a salesperson can be an agent for many customers. A salesperson can be an agent for customer. That is our next relationship. A salesperson can be an agent for many customer. Okay, a salesperson can be an agent for many customer. A salesperson, a single salesperson can be an agent for many customers. So the cardinality ratio is 1 to many. Okay, 1 to many. Okay, what will be the reverse case? The reverse case is also given. A customer is managed by exactly one salesperson. A single customer will be managed by only a single salesperson. So here the cardinality ratio is 1 to many. Okay, so in both way, the relationship has been specified here. Okay, both entity, the both ways the relationship has been specified. Okay, here the salesperson can be an agent to many customers. That is this way. A salesperson can be agent for many customers. A customer is managed exactly by one salesperson. A single customer will be managed by a single salesperson. Okay. Next statement, what? A customer can place any number of orders. A customer can place any number of orders. Next relationship. Okay, a customer can place any number of orders, right? A single customer can place any number of orders. Okay, now the reverse way. An order can be placed exactly by one customer, and a single order can be placed exactly by a single customer. So the cardinality ratio is 1 to many. Okay, so the relationship is actually specified in detail here. In both way, it has been specified in the question itself. Okay, a customer can place any number of orders that we have already completed, and an order can be placed exactly by a single customer. Next one, each order list one or more item. Each order list one or more item. That is our next task, next relationship. Each order list one or more item. Okay, so each order list one or more item. Clear? In reverse way, what? An item may be listed in many orders. A single item may be listed in many orders. So the cardinality ratio is many to many. Okay, so it is specifically given in the question paper. Next one, an item is assembled from different parts and the parts can be common for many items. So this item, the item is actually a product. A item or a product is assembled from different parts. Okay, so next entity is parts and our next relationship is assembled. Item is assembled from parts. Okay, so a single item is assembled from different parts, many parts. Okay, a item is assembled from different parts. Okay, in reverse way, what is it? And a part can be common for many items. A part can be common for many items. Okay, a single part can be common for many items. So here the relationship is many to many. Okay. Next statement is given, one or more employees assemble an item. One or more, so this item will be assembled by one or more employees. So next entity we are going to create is assemble and the employee, and the relationship is assembled. See, so one or more employee, an item will be assembled by, or a product will be assembled by one or more employee. Clear? So that is what is given the statement. So an employee can assemble many items. See, both way it is right. An item is assembled by many employees. and an employee can assemble different items or multiple items. So the relationship is many to many. Okay. So this is over. Next is about a supplier can supply different parts in a certain quantity. Say supplier. Here we are going to create a new entity called a supplier. So supplier can supply different parts. Supplier can supply different parts. So supplier can supply different parts in certain quantity. So next entity is supplier, and the relationship is supply. Okay. See, supplier. A supplier can supply many parts. Okay. Next, a part can be supplied by different supplier. A single part can be supplied by different supplier. So this is the question. So based on this question, we can create the ER diagram. So it is here in this question they have not asked to write the attributes. See, we didn't write any attribute here. Okay, so when we write these attributes, this ER diagram will be a full mess. Okay, full of entities will be when we cover this entire entities, it will be a full mess. So in certain questions they will not ask to write the attribute. Okay, so they just write to the statements, the entities and the relationship will be given. Okay, in these type of questions also they will ask to write they will ask us to choose certain entities, certain attributes of our own. In that case we have to write our own attributes. For example, salesperson, we can write salesperson's ID, salesperson name, location and so on. For customer, customer ID, customer name, salary, so on, etc. Order, order ID, order number, order name, etc. Item, item number, item name, etc. Okay, essential attributes we have to assume and write. In that case, if it is not given in the question paper, the attributes we have to identify and write. Okay, so this is an example for a ER diagram. Okay. So I have discussed two examples, and I will give one or two exercise to work it out. Okay. Only after working out we will be clear with these concepts. Okay. Thank you.